Hello everyone, in this video we are going to learn about two very important data structures and these are stack and queue. These are used in many problems like valid parenthesis problem, BFS and DFS traversal of graph and trees and many more problems. So in today's video we'll study about stack and queues and we'll look at the various operations that we perform on stack and queues and we'll also see a few problems using stack and queue. Stack is like a linear data structure that follows LIFO principle. Okay, what does LIFO means? LIFO means that the element that gets into the stack at last will be taken out first, right? It's the similar as the stack of plates, right? Here we have a stack of plates, right? And we have placed this um, plate at the last. So if we want to take out plates, then this plate that is placed at the last will be taken out first, right? And the similar goes with the data structure stack, right? That if we do if we want to take out elements from the stack, then the element that has entered into the stack will be taken out first, right? So let's now look at the operations that we can perform on stack, right? So the first operation that we are going to see is push. As the name suggests that it pushes the elements into the stack, right? So let me take out all the elements from the stack. Okay. So initially the stack looks empty, right? It does not have any element. So if we do push 3, then it will push 3 into the stack. Now again if we do push 4, it will push 4 into the stack and stack will look like this, right? Now again if I do push 5, then the stack will look like this. Okay. Now, the next operation is pop. What it does, it removes the element from the stack, right? And the very important thing is that it removes the element from top. Means the element that has entered into the stack at last will be taken out first, right? As we have seen that 5 has entered into the stack at last, then it will be taken out first, right? So if we do pop, then 5 will come out of the stack. Now again if we do pop operation on the stack, then 4 will come out of the stack. Now again if we perform pop operation onto the stack, then 3 will come out of the stack. And after that stack will look empty. Okay. Now look, now let's look on the next operation, that is top. What does top do? It simply returns the top element of the stack. Okay, it sees what is the top element of the stack and it returns us. But the very important thing that we have to notice that it does not remove the top element. Instead it just sees what is the top element and it returns it, right? But what pop does, pop removes the element from the stack, right? Okay, so let's now look at the next operation that we can perform on stack is empty. Empty returns it simply returns boolean values, true or false, right? So if we perform empty operation on the stack, it returns true. When it returns true, it returns true if the stack is empty, right? And it returns false if the stack is not empty. Okay, so let's now um, go to the Visual Studio Code and let's look into this, that how we can perform this operation on stack. Okay, so let's now look that how we can use stack. Okay, so to initialize stack we can simply write stack and whatever data type value we want to store into the stack, like we were storing integer values, so we'll use int here. Okay, and identifier. After that we have initialized an stack. Okay, now let's push an element 3 into the stack and after that we'll push 4 into the stack and after that we'll push 5 into the stack, right? So now the stack looks something like we have pushed 3 into the stack, pushed 4 into the stack and pushed 5 into the stack, and now the stack looks something like this, right? Okay, so if we does st dot top, then what would it return? Hmm? Let's look at this. Look, it returned us 5. Why? Because the top element is 5. Okay, good. Let's now access all the elements of the stack, okay, one by one. So here we'll simply write while not stack is empty. Okay, till then what we'll do is cout st dot top. We'll print, here we are printing the top element, and we'll remove that element from the stack. Okay, and we are doing it till stack has an element. Okay, let's now run this command. uh, there we go. Okay, the output is 4 3 5 4 and 3, right? So as you can see that here we have pushed 5 at the last, and when we are accessing the elements, right, then 5 is accessed first, then after that 4, then comes 3, right? Okay, let's now see here what has happened. Here we have, look, here we are printing the top element, right? Whatever is the top element, we are printing that, and after that we are removing it. Next comes 4, we print 4 and removed it. Next comes 3, we look at the top element of the stack and print it and removed it. And now since the stack is empty, the condition is violated and the loop breaks, it stops, right? Okay, so let's now look on queues. Okay, so let's now look on queue. Uh, queue is a linear data structure that follows FIFO principle. What does FIFO means? FIFO means the element that has entered into the queue first will be taken out first, right? Means if we want to take out an element from this queue, then the element that has entered into the queue will be taken out first, right? Here if we want to take out element, 3 comes, right? And after that if we again want to take out an element from the queue, then 4 will be taken out, right? And again if we want to take out an element from the queue, then 5 will be taken out. Okay, so let's now look on the operations that we can perform on queue. So the first operation is push operation. As the name suggests that push is used to push an element into the queue, right? Okay, so if initially the queue is empty, let's take out all the elements. Okay, so initially if queue is empty and we perform that push 3, then 3 will be pushed into the queue like this. Okay, then if we perform push 4, then 4 will be pushed into the queue and queue will look like this. Okay, and again if we do push 5, then 5 will be pushed into the queue and the queue will look like this. Okay, let's now look on the next operation, that is pop operation. What it does, uh, it removes element from the front of the queue, right? Okay, so if we do pop operation on this queue, then 3 will be taken out. And again if we do pop operation, then 4 will be taken out. And again if we will do pop, then 5 will be taken out. Okay, so as we have seen that the element that has entered into the queue first, that is 3, is taken out first, right? So it seems to follow the FIFO principle, that is the element that has entered into the queue first is taken out first, right? Okay, now let's look on the next operation, that is front. What it does, it just sees what is the front element of the queue and it returns it, right? It does not removes it. Instead it just sees what is the front element, here it is 3, so it will return us 3, right? Okay, so the next operation is empty. It is similar to stack, right? It returns boolean value true if queue will be empty, right? And it will return us false if queue will not be empty. Okay, so let's now look all these operations on Visual Studio. Okay, so to initialize queue, we simply write queue and whatever data type value we want to store in queue and identifier. Okay, here we have initialized a queue, right? Let's push elements into it. We have pushed 3, and after that we'll push 4, and then we'll push 5 into the queue, right? And now the queue looks like this, right? We have pushed 3, then we have pushed 4, then we have pushed 5 into the queue. Okay. Okay, let's now look what's the front element of the queue. Okay, so we'll print queue dot front. What will it do? It will return us the front value, right? Look, it returned 3 and the front element was 3, right? Okay, so let's remove the front element, that is 3, and after that we'll look what's the front element after removing 3. Oh, it's my bad. Here we have to do q dot pop, right? Okay, there we go. We have got 4, right? After removing 3, we have got the front element as 4 because now the front element is 4 and we have print that. Okay, so let's now access all the elements. So here we'll take a while loop, while not q dot empty, till then print the front element, right? Q dot front, print the front element and remove that front element. Okay, there we go. Let's look at this. Okay, as you can see that the output is 3, 4 and 5. That is the element that entered into the queue first is taken out of the queue at first, right? It is printed and then taken out, right? What we have done is, look what we do. Here we have printed the front element and after that we removed it, right? Here we printed 3 and removed it from the queue. Then the front element is 4. So here we printed the front element and removed it. Now the front element is 5. We printed the front element and we removed it from the queue. And since now the queue is empty, so the condition is unsatisfied and the loop stops, right? And we have got the output as 3, 4 and 5. Okay. So the time complexity of each operation that we are performing here is big often, right? If we push an element into the queue, like if we push 3, then it's taking order of 1 time complexity. If we push 4, then it's taking order of n time complexity. If we push 5, it's taking order of 1 time complexity, right? And similarly pop, front and empty, these two takes order of 1 time complexity, right?